All right, I think we exist. All right, I think today is September 4th, 2025. We're in our third week here in CSE466. I am not Michael Tompkins. I am Robert Rossinger, but I stole his slides. So, memes. First up, we had a couple memes that kind of dunked on me being live, right? I think part of the fun and the value of having class is doing live things, not talking to slides. So some people dunked on me for the canary, kind of randomly getting that null byte, right? I think that's great. Like, I'm going to make mistakes more than likely in this demo. I'm going to be very impressed with myself if I successfully pull off this demo today.
It wasn't really a mistake though, because it was random chance.
It was random chance, but like these type of things are part of the value of doing live demos, right? Like things will blow up, and sometimes it will be a dumpster fire. I'll do my best to not do that, but we'll see. In case you're unaware, we do have a live stream, like a podcast we do every couple of weeks, where we talk about pwn.college related things. Somebody decided that was a great snapshot of me being bewildered at something. We're getting some more of these challenges here, tips and tricks. So like to see it. We had a lot of good memes over the past week or so. So if you are trying to lead the canary, one of the tricks that you hopefully learned in the earlier challenges and is relevant in the later challenges is printf. Why is printf valuable? Yes.
Stop them, no line.
Right. If we printf %s, then printf is going to try and interpret a string. A string terminates with a null byte. So if somehow we manage to get bytes of a string right up against something, we can utilize that to leak out information that we otherwise couldn't. This meme here is also relevant to some of the educational challenges as well as the later challenges by design. What are we talking about over here? It says input size checker, some crazy large number, but in 2's complement, this is a really big number. Right? Is the number signed or unsigned, right? If you don't have to necessarily know 2's complement, but if the leading bit, the most significant bit, is a 1 and we interpret it as a signed number, then it is going to be negative. But if we interpret it as an unsigned number, it's going to be very large. And so this is something that we can also abuse if we understand the context that these bytes are being interpreted as. These type of memes will definitely increase. GDB enjoyers. Over the course of this semester, you'll get to see lots of interesting GDB tricks, including today. And you will learn to love GDB as I do. The probably most talked about thing in the class so far has been the last 3 challenges, which are the fizz-buzz kind of monster scary ones. There were a couple of memes a week or 2 ago when the challenge series launched that people didn't really understand and appreciate. However, you've turned around and started making some of these memes that share a bit more about the challenge. So like the very last one, there's no executable stack, there is no win function. There is something that is a starting point for how you solve this challenge. But it is not trivial, it is not straightforward, and you'll have to apply multiple techniques that you learned in the earlier ones. Stack address, red address right there. Yeah, it looks easy until you start going at it, and it's not. I also can't type. That's going to be common. So, state of the class. We are past the drop deadline, so I'm done telling you this is hard, spooky, scary. You've all made your choice. There's 132 people that registered for the course. There's 56 when I looked earlier today that are registered in the class. This does not concern me at all. This is honestly not the worst that it's been. It's not the best that it's been. This is part of the course. So there's 9 students that either haven't started anything or have not linked their ASU ID. If you don't do that by the end of the semester, you just don't get a grade. So hopefully at some point between now and then you do it. As modules wrap up, I will provide, I or Michael will provide some slides on grades. Things that we look at is what was class average, what was the variance, what was the solve rate. So I care if you guys started early or started late. If everybody did bad, but then I look at the class and everyone started 3 days before it's due, that's on you, right? But if people start early and we're struggling as we move through, okay, then maybe there's something we can do to address that, right? If there is some metric that you're interested in as we go through the course, please mention it to me outside of class, and I'll consider throwing it up in the slides because we try and be as transparent as we can about how we're doing things and how the classes go. Logistics. I feel like there should be another couple points here. Class next week, Thursday, will be remote. There will be no in-person. I'm traveling for the university, which means I cannot be here next week. I will stream it on Twitch. We'll try and do the best we can, put some cool demo, but I won't physically be here. So you're welcome to show up, but there'll be no one else here. The grades page is still broken. It's on my to-do list. I haven't fixed it as far as the mean math is concerned. This is showing an updated slide because why not? I had another bullet that said office hours. It's one of the things that I stressed, and we have stressed in all of these kind of opening segments, is show up to office hours, ask questions, etc. I check with the TAs and see how people are doing. It looks like yesterday, a lot of people showed up. That's great to hear. Hopefully they were helpful and they got you unstuck and whatever you were stuck on. One of the things that we're looking at right now, if you guys continue to show up in that size, is adding more people so that you can get more help, including myself showing up to like some office hours to just help pad the staff side. So like, if you feel that we're understaffed, let me know. We'll try and fix it. It's way more important that you can get help if you show up and ask for it. All right, demo plans. There were two things people asked about. Somebody said, hey, explain to me how stack frames work. And then the other thing was, give me something that is like FizzBuzz tier. And FizzBuzz tier is a tough thing to do without just like giving you FizzBuzz. So I had to think about it for a while, but I think I put something together that will be just as painful. Does anyone have anything else that you would like me to touch on before I get started? No. All right. So pull up good old pwn.college here. Find the demo dojo where I'm hiding things. And I added a challenge called complex corruption, or demo, I should say. Okay. So first and foremost, we can look at the source on this because it's a demo. So we can save us all the headache of what has happened. All right. It's going to make the conversation a lot easier. This challenge is not particularly tricky. It's got a little bit more code than FizzBuzz, but not much. This is, I think I called it Corruptible Cat. All right. It's the world's lamest cat program. It's an interactive cat. What we do is we loop infinitely. We're going to prompt you for a file name or the keyword exit. If it is exit, then we break out of this infinite loop and the program terminates. If we get a file name, then we're going to ask for an offset into this file. You provide an offset, so the number of bytes you want to begin reading in this file, and then we call this write file function. The fun stuff is up here in write file. So this is some magic I have to do to make things, make the compiler do what I want. We can think of it as just local variables that are on the stack. I have a buffer. I have a file size, so an int. I have a pointer called the offset pointer. I have this thing called snapbuff, which we haven't talked about, so that'll be fun. We have a file descriptor, and this is all in just one big struct, which ensures these values are in order as defined in the source code. Where am I? Okay. If we're given an offset, then we figure out where this offset is into a buffer, right? So you say you want to be 3 bytes into it. I have a pointer at the start of this buffer. I'm going to go 3 bytes past it. Is everyone aware that an array and a pointer are functionally the same? Okay, most people don't know that. I didn't know that in several years when I was doing this. But the way that an array is implemented is it is a pointer. And so when you index into an array, you are just taking that base address of the array and then adding some offset. Here it's a character array. So when I do the base address of this buffer plus some constant that's equal to, say I'm going 5 characters in, it's 5 bytes in, it's all the same. Okay, then we're going to open this file name that was specified. We're going to call fstat. Does anyone know what fstat is? That's okay. Does anyone know how we can find out what fstat is? That's right, the man page. B. So, if we man fstat, what we see here is it is a crazy looking thing. It says fstat is identical to stat. Well, what the heck is stat? Stat and fstat retrieve information about a file pointed to by path name, or you can define it by file descriptor, right? So I'm just getting some information about the file in C. And it is provided in this really complicated struct. But if we read the documentation here, it tells us what all of these things are. They're the kind of things you would expect if you want to get information about a file. All right, so I'm getting some information about the file that was specified. I'm then going to read and write that file. So I'm going to read the contents of the file from that file descriptor that we opened into our buffer, or however big the file is. We're then going to close the file, and then we're going to print out whatever is at that location. Does everyone understand how this program is supposed to work? Yes? Beautiful. Has anyone seen anything that looks not cool so far in this program? Yeah. Was there? It looked totally good. So my build.sh, all I'm giving us something. We're compiling this with an executable stack. Right? We could check sec, as somebody mentioned. And that's unfortunate. I wanted PIE, but it did no binary. Gosh dang it, the dojo. This breaks the whole demo. This is what I get for deving off of the dojo. App stack. Is that right? Or it's 4 stack protector. It's a good thing we ran checksec, otherwise I'd be very confused. All right, that gets me close enough. We're going to pretend that this address is randomized because I don't know from the top of my head. Does anyone else know what the GCC flags are to force PIE? Actually, I think I do.
PIE.
Yeah, there's F PIE and then it's dash PIE. I think that one might have to go at the end. PIE, okay. It doesn't like this. Doesn't like okay.
I like that one. The second one. Pretty sure you just need that PIE.
Well, one goes to the compiler and the other one goes to the linker, but if as long as the dojo's happy, I'm happy. See? Yeah. Got it. So I had to throw it at the end because at the end it goes to the linker because there's a linker flag in between. So we have a canary, we have PIE, but we do have an executable stack. I could force railroad. I don't care. It's not relevant for our purposes here. All right. So let's run this thing. Let's echo A into the file A. I'm going to run our binary. I give it the file A at offset 0. It says A. Let's echo ABC into A. Let's run our binary. Oops. Echo ABC into A. Let's run our binary. Let's say I want A. I want offset 1. What would you expect? BC. Okay, so it does behave how we would expect. Did anyone spot memory corruption in here? Turns out there's more than we need.
Your printf was.
Okay, so somebody found printf. Printf itself is not bad, right? Like printf is our friend. Yes.
Happens to you scan out the big number.
What happens if I give scanf a big number?
Like,
Where am I? For the offset?
I think it was in the other file actually.
That's all one file. I'm just higher up here.
Yeah. I still don't call it for the offset or if it's marking sub file.
Okay, so that's one problem, which we will need, but you correctly observed, right? This offset number doesn't bounds check the file. That's one problem in this program. What else is going on? Generally speaking, when you're thinking about like buffer overflows, memory corruption, what are the things you want to all like fixate on? Size of the buffer, and then how many bytes can I get into it? Is there a problem with that type of logic in this code?
What is stat STL for size on?
What is statbuff.st size? Okay, that was used in fstat. How did we find out what fstat was? We went to the man page. So we did man fstat, which we did earlier. When we looked at what the fstat command is, it takes a pointer to this stat buff structure, which we don't necessarily need to delve into. But if we were to go down a bit in this man page, we see this is the definition of that struct. This struct contains a bunch of different members that are properties of files that we may be interested in. There is not a trap hiding in the implementation of fstat. I'm not doing that to you. That would be, I feel, a little bit unfair. We can reasonably say that this is getting us the size of the file. How big is my buffer that I'm putting stuff into? 256. How many bytes am I reading into that buffer? Depends on the file. Why do you say that? Like it's correct, but well, how did we get there? Okay, we get the size, and then that is our third argument to read, and so that determines how many bytes we're reading into this, right? This isn't a straightforward, just cat in a whole bunch of A's. That would not be fun at all. So we have the ability to pass more input than expected. Oh, Dojo, if you keep doing this, I am not going to demo on the Dojo. It probably won't be streamed either because I'll just SSH to a server of mine. But, we're going to create my favorite file, do.py. We're going to give it some boilerplate. User ben n, Python 3, from pwn import star, context arch equals AMD 64. Okay. So, how do I find where this corruption is? We talked about a couple strategies. There were some memes in it earlier. Some people like GDB. Some people like cyclic. What do you want to do?
GDB.
You want to use GDB? Okay. So what do? I'm going to GDB debug. A dot out. Do we want to do anything else with it? I'm going to always end with P interactive. It's a good practice. Do we want to send anything to this? Okay, so someone is thinking ahead, right? If we run this guy, once the Dojo catches up with what I'm doing, it prompts for a file name. Anyone have a strategy for how we can like interact with this program all within our Python file? I'm sorry? Okay, so I could use my Python to send a file name. Should I use send or send line and why?
Send.
Somebody says send.
Send line appends 0A at the end of whatever you pass.
Okay, so send line does append the 0A to the end, which is a new line character. How is this program getting input?
Scan.
Right, it's using scanf, which determines arguments They're split on white space, and a new line character is white space. So if I use send, I would need to include either a new line character or a space. Anyway, whenever we are interacting with the program like this in Python, the question you always want to ask is, how is this thing taking in input? What is the function? And you could be like, Robert, I don't know about scanf. I've never seen this thing before. What's the answer? There we go, the man page. So we could go man scanf, and if we were to read this, it's going to say it reads input from standard in, and somewhere in here, it's going to say it's separated by white space characters. Does somebody see it? At the bottom. Near the bottom.
The very bottom.
No, maybe it's a little bit lower. Maybe I'm hiding it from ourselves. You're just going to have to trust me because I know I have a lot to do with this demo. But it's in the demand page here. So we want to use send line. Okay, what do we want to call our file name? I don't know. My exploit file. Cool. Then I would recommend doing this side by side if you're not familiar with what the program's going to do. Now it's going to ask for an offset. How do I deal with this? Somebody says send. It's still using scanf. We take a look. So send line is an optimal way of doing this. Send line, I need to send it a string or a byte string. Otherwise, pwn.tools will be grumpy. All right, that is sufficient to interact with this thing. And then let's wrap up and be clean. Oops. If we do all caps exit, it just cleanly exits. So let's have that at the end. All right, but now I have to make this file. So my exploit contents equals, we don't know. I'm going to use cyclic 300. And say with open my exploit file. I'm going to write this in a binary, open this for write in a binary format because I want to write bytes. And I want to, as f dot write my exploit contents. What I'm doing here is I'm just setting up some boilerplate code so that my Python is creating the file because I have to interact with this thing now via file contents as well as interacting with it programmatically as if I were typing. I'm sorry? Second to last line. Where am I?
Your send line exit.
Can you send line exit? You don't like this? Oh, make it bytes? You don't have to, but pwn.tools will give you a warning. And if you get 1,000 warnings, it floods your screen, which is kind of annoying. All right, cool. Let's run this thing. chmod +x do.py. pwn.tools is not happy. No a.out. What did I do? Could not find none. From pwn import star p equals gdb debug user bin m python. What is it grumpy about? ls, there is an a.out. Oh, Dojo. I don't think that's the case, but we'll find out together here. It is. Okay. So I've attached GDB to this thing. Remember, if we use pwn debug, it's going to set a breakpoint at start. So we're going to just continue onward because we expect this thing to not be happy. Turns out it exploded. Did I overwrite a canary? Why did I explode?
Sent one 256 bytes.
Okay, somebody says something about 256 bytes. This is where stack frames are relevant. I use this a little bit. Does anyone know what this right here is called? It's a backtrace or a call stack, right? If we think of a program as main being the first thing in the program that's called, main is calling write file, which makes sense when you looked at the code. Write file is calling puts. Puts is trying to find the length of some string that is being put, right? And it is grumpy because it's seg faulted, and it's seg faulted trying to access RAX. What is RAX? It's this. Does this value look like something?
Looks like you're cyclic.
It looks like a cyclic value, right? Now, I could delve into the implementation of puts and be like, why is puts calling string length and figure all this out, right? But what is the only thing I pass to puts as a like, normal user? I give it the string I want to print. So instead of being in the guts of this thing, let's be in write file. And what I'm interested in is where is puts called? It's called right here. Now this has already happened. I've blown up this time. What I want to do is I want to inspect what's happening right before we call puts. So where do I set a breakpoint? Right before puts, which is going to be at write file plus 239. Now you saw me last week type break whatever like 50,000 times, right? It turns out there is a better way. You can programmatically set your breakpoint. Your second argument to gdb.debug is your GDB script of what you want to run. So I said I wanted to break where? Was it write file? Write file plus some number. Write file plus 239. I want to break right before this puts call, right? Because I could be down in the guts of puts inside of string length. That sounds like pain. The only thing that program passes to puts is a pointer. So if I break right before puts is called, I can see what puts is getting as a pointer. Yeah? So we'll set a breakpoint right here. And then I have C, which is shorthand for continue. We'll get out of here because we've seen that we blow up, but I want to reason about this a little bit better. You'll notice that I didn't end up at underscore start. I am now exactly where I want to be from immediately firing this. Because the commands that I was typing repeatedly, I have now placed in my exploit script. What do I want to do when I fire this? I want to set a breakpoint at write file plus 239, and then I want to immediately continue execution because I don't want to be waiting at underscore start. All right, we're about to call puts. What argument is the first, what register is the first argument to a function? RDI. So if I print RDI, I get another number. Does number look familiar? Looks like a cyclic value. How do I find the location of this cyclic value? Okay, so there's cyclic find if I am in a Python session here. We can go from component import star. Maybe, come on, Dojo. We can cyclic find. The Dojo is very not happy, but it did produce a number. Hopefully it's a good number, 264. What does that 264 tell me? It's 264 bytes into my payload, into my cyclic value, where I now have control of this puts pointer, right? Can I use this in any way, shape, or form? You said 264. So I'm going to say BA times 264, right? And we'll add a little note to ourselves. After this is a pointer that puts is called on. What do we want to do now? Can I overwrite this pointer? Do I know a good value to put there right now? No. Okay. Is there anything else I could do?
I would just send it and see what happens.
You want to send just the A's as it is?
Yeah.
Okay. Why is that something you want to do? It just feels good?
Well, maybe there's like something, because right after 264 it crashes, right?
Right after 264, it crashes.
Maybe see what is causing it to crash.
Okay. So I'm going to just change our payload, right? So we have just the A's. We're still breaking at that same spot right before puts call. I'm doing that so I'm breaking at a known point in the program before crazy happens. Two, 9. That just didn't write. Okay. Boom, we're right here. If we print RDI, this now looks like a valid pointer. How do I reason about how my A's relate to this pointer in GDB? We're using GDB. Let's look at some memory. What do you want to do?
XGX right there.
You want to XGX this right here? Let's do, I don't know, 4GX. All right, we got some A's, right? So this is a pointer that is pointing to probably the beginning of our payload, yeah? What do you think we'll see if I dump out more? 29 is a weird number, but I guess we need more. Here's all my A's. What is this?
It's the pointer where like
It's that pointer that we're overwriting. Okay. So we're about to put all of our A's, and when does a string terminate? Null byte. This isn't specific to printf. This is how strings work, right? So if I were to continue execution, what is puts going to output? The pointer, right? It's going to start here, and it's going to, and then it reads backwards, right? And so we're not using printf here. We're using puts, and we're getting that pointer. How do I capture that pointer? Because that seems like a useful thing to have, right? That's information that I wouldn't otherwise have. And just to show that it is happening, we have that right up here, right? These crazy bytes, that's our pointer. Okay, we want to do a receive until here. What am I receiving until? I'm sorry? That's interesting.
Does that work?
It probably will work. It's not what I do, but I'm happy to give it a shot, right? This is a team building exercise. All right, so then what do I do after this?
P.receive.
P.receive. You want a line?
Do 7.
So it is calling puts. I imagine there's an end line. There is a new line here, right? Did we see that return? Do you want to trust that new line?
Let's give it a try.
Okay. All right. When we don't finish the demo, we'll know why. Okay. So this will be our. Do we know where this is in memory? Is it? What am I leaving?
The stack address.
I'm leaving a stack address. So I have stack leak equals receive line. I'm going to do another trick that you will probably find yourself doing while you're writing exploits. You can add the following 2 lines, basically anywhere in a Python program, import IPython. Notice the capital letters, they do matter. And then IPython embed. I screwed up the capital letters as I was telling you it. The capital letters matter. What this will do is at that point in execution, our exploit will turn into an interactive Python session.
It's a pitch using GDB.
Okay. So our Python script is waiting. We have interactive Python terminal up here. The reason that, so I have GDB down at the bottom. GDB is just continuing, letting things run free. And my Python, my exploit is now giving me a Python prompt. What this allows me to do is reason about the state of my code at this point. So like something I may want to know is what the heck is stack leak? Did we actually get it? Right? This is what we got until the dojos decided no. Okay, I'm just going to ignore the dojo exploding on us. These are the bytes that we got. Is that what I wanted with receive line? Is there a problem with that? I'm sorry?
Yeah,
Right, we have the new line character there, and we got to get rid of it. So we can use receive line, but now I need to drop the last character or last byte of that byte string. Is that a hand? I'm sorry?
Keep
Keep
ends.
keep ends.
So the parameter to receive line.
Or you can do this dot string.
Or keep ends one word. Or people call it.
Okay. I don't know that one. I'll go with it. Like I learn stuff every time I teach the class, so this is awesome for me. So we could have done this. We could have used somebody said strip, right, to strip the new line characters. I'm not a fan of using strip. The reason for that is it may unintentionally, like what if the last byte of what you're leaking is hex 20, which happens to be a space. Strip will remove stuff that you might have needed. I don't know what keep ends does, right? I'm assuming that it is smart and only removes the literal new line character. Should is a bad word in this class. So in the interest of doing something that will always work, I'm going to index this as an array and say I do not want that last character, that last byte. This is always going to only drop the last byte. So I'm going to say that for now, this is the most correct thing I could do. What else do I need to do? I want to turn this into, how do we store addresses? What's best practice? Right, we want to use 64. We want to store it as a number. What is the one thing that U64 asks?
It's 8 bytes.
It's 8 bytes. Do I have 8 bytes here? Okay, how do I fix that? It's one of the justs. I'm going to claim it's L just because this isn't the canary. The canary is the one that trolls us. Generally speaking,
It's just.
it's just. Yeah. L just is what I'm after. So hopefully this adds us to 8 bytes, gives us a value that we're interested in. Let's see something here. Is my Python, what did I call this, stack leak? Okay, so I have this. So despite the dojo trolling me to the nth degree, we could say hex U64 in my interactive session here. I'm like verifying that what I'm doing makes sense instead of like running it and my code explodes. Let's run it in the interactive session and make sure what we're doing gives us what we want. So I have U64 of stack leak, except I'm dropping the last byte. And then I am L-justing that 8 with null bytes. Oh, dojo. Did it at least output something useful? It did not. All right. We are currently just cursed by the dojo. So instead, am I off by a paren here somewhere? At the end? Cool. Yes. All right. We can, at least in our code, print this. I'll say stack leak.
Exactly. That's
Good call. Did this print anything? Okay, it did. So apparently just the dojo doesn't like the interactive session at the moment. Does that look like a valid address? Okay, so now I have a stack leak. How does this help me? Okay, so one thing is once we have a leak, we can know where anything else is relative to that leak, right? Since we have a stack leak, we can calculate the location of anything on the stack. That's one thing that's true. This challenge has an executable stack, right? Do we currently have a means to redirect control flow?
yes.
You say yes. Okay, so one thing that we may want to do is overwrite the saved return address to get this to return to somewhere we're interested in. Yeah? Can I get to the saved return address right now? Why or why not? Okay, there's no win function, but we have an executable stack. Right? I just want to get there. If I can put A's there, I'm feeling better than I was. Can I get A's at the saved return address right now? No. Okay. So what is your next step? What are you thinking we need to do? So far, and this is what you should do when you're looking at the FizzBuzz. Here, we have the benefit of I'm sharing the source code with you. When you are doing the FizzBuzz challenges, you do not get the source. You instead look at like item, right? But what you want to do is you want to think about what are the values on the stack and in what order are they as you corrupt them. So we filled this buffer. Somewhere along the way, we overflowed past this file size number, but that didn't cause anything to blow up. We blew up because we were overwriting this offset pointer. What is after that? That's that crazy stat there. Do you think I can clobber that? Oh, how's it used in the program? It's used up here. Here's my read call. Is it used at any point after that? No. So it's just space that we can mess up, right? It's not going to break the functionality of the program. But how do I get past that pointer with this leaf? I can overwrite the pointer with itself. I know that's a good value, right? And this program does let me interact with it multiple times, right? We said there was an infinite loop until it gets this exit thing, until it receives exit. So can I make a second file that has a smarter payload? Yeah. So let's yoink our little file creation logic. Boop. And we're going to call this my exploit 2 contents in my exploit 2 file. All right. So what's my payload for round 2 going to be? I've got 264 A's followed by, you already said it, the stack leak. What do I need to do to the stack leak?
P64
I need a P64. What does P64 do?
packs it. It makes a little, it adds little bytes.
Right. The statement was, it makes it 8 bytes. It takes care of the little Indian. It packs it, makes sure that it's an 8-byte value. That's why it's P64. All right, cool. So I have this. How do I figure out how much further I need to go? Where am I trying to get to? Let's fire this as is. All right, I'm still right before that puts call, but that's fine. Let's print RDI so I have it. And let's just dump out, I don't know, 80 giant hex at that location. All right, there's my A's. There's the pointer that I'm going to overwrite with itself for my second payload. Where do I want to get to and how do I know? It's not on the screen right now. There's something I need to type.
Info frame.
Info frame. So I do info frame. This tells me where the saved RIP is. It says the saved RIP is at 2038. That's going to be this value right here. What is something that is stopping us from getting to that value right now? The canary. Do we have a solution for getting to the canary? You can leak the canary. Okay? How do you want to do that?
So right now,
Same way we did it. Let's do that. You may have thought ahead.
yeah.
I'm going to do it the same way. This was an intentional troll. Okay. How do I know? Oh, I didn't do that. Let's figure out how far away it is. How do I figure out how far away these two things are? Math. There's not a lot of math in this class, but there is some. Examine 60 giant hex RDI, info frame. So we have something that looks like this. What values do I care about? What do I subtract from what?
Address of the start of the buffer.
Address of the canary from, somebody said the start of the buffer. We could use that, but I already have stuff in my payload, right?
From that pointer though.
From that pointer, we can do that. So that pointer is located right here. That's going to be 1128. And then the canary is located, anyone spot the canary?
C8.
C8. How do we know? Because it ends in a 0 and it's protecting stuff that is juicy. So we'll take this, crack that to an 8, subtract where our pointer is, which is this.
It would be 1020, right? Because that's the address that we have. I mean, the value that we have in our code.
You're saying this value should be,
Yeah, it should be 1020.
so this depends on what you're trying to calculate, right? Both, we can use either value, right? We could say that the distance from the beginning of our buffer to the canary is some value, and then use like LJust to always pad, right? The other way that we can think about it is, I have a payload that is going to have all these A's plus this pointer. What I care about is what is the remaining distance. Both ways work. It all depends on what makes more sense to you. Right?
So then when do we do it from 11:30 then?
What did I do? Oh, was that the statement? We should be at not 11:28, but
The address
11:30.
is 1020.
So 1120 is this byte right here.
Yeah.
This is 1127. This is 1128, which is what I messed up when you caught me. So it should be 1130, right? It's going to be the spot. So I did do the math wrong. So you want to do this? Yeah. All right. Cool. I get hex 98. So my second payload is going to be, I'm going to change the character from A to B. This is a good practice when you're writing your code. What did I do? Quit. You're good. This is here. Oh, I didn't actually interact with the program. I just wrote a file. So I should probably communicate with the program and tell it to look at our file, right? Might be useful. And this is my exploit2 file. Okay. And I still have, just to point this out, because it's useful for debugging, this like perennial breakpoint that is at the perfect spot for me to think about what's going on in memory, right? Well, notice that I'm not breaking every time in GDB. Okay. Is this the point that I'm interested in? No. Why? This is the first call to puts. We'll continue. All right, we blew up. Exit code 3. And we have the benefit here of the source. Exit 3 is if close returned a bad value. Why did close return a bad value? Right, we overwrite this file descriptor, right? It turns out I didn't have to care about this stat buff thing. I do have to care about that file descriptor and make that right, or else this program is just not going to work. We can't get there. How do I figure out where this file descriptor is? What do you want to do? Somebody says, look at the stack. Okay. When in execution should I look at the stack?
Before we load the contents of the file,
Before I load the contents of the file?
like in memory. Because like that's what is overriding all of the.
Or the second payload.
Before the second payload is set. Okay.
Of course, we're not the stat.
Well, I'm saying like right now, where do I set a breakpoint? What do I do? What's my get me there?
Don't we need to break before the file's loaded, but then after, so we can see
Before
that how you get it?
So the one thing that I have to do for sure is break before this close. Everything else before that is up for whatever you want to do. So tell me what we're doing and let's do it.
And then we like analyze the stack to see what
Okay.
the file descriptor value was.
So I can break it read. It's a valid place. It's before close. I'll take it. Do I care about this one? No, it's the first read. I'm at the second read. What do I do from here? I'm sorry? Well, I want to, with read, the thing I'm most interested in is where are these bytes going? What register is that? RSI. This is the location where those bytes are going to be written. All right, I'm going to finish because I want to get out of read. I want to spend the least amount of time inside of implementation details. I want to be in the program's logic, not in the libc wrappers syscalls. So I'm going to finish. I could examine, I don't know, what do you want? 60 giant hex at RSI. Oh, I'm sorry, $1 because that's been changed. Did I learn anything new? I learned that wasn't the recall I wanted, but because I don't have the B's, right? I see all of the A's. I don't see any B's in here. Yeah.
Well, presumably the file descriptor is one of those values that's on stack right now.
Okay.
It's like a 1. That's
So somebody is saying, I bet that one is the file descriptor.
I did that one.
Oh, there's another one. It could be this one. Is that an optimal way of figuring out what's going on in a program? Okay, does anyone have a better way? It could be. I don't think it's 1. The reason I say that is what do we know about 1, the file descriptor 1? It's standard out. So it's probably not 1. It could be. There are some challenges where we close file descriptors and you get weird troll things like that. But we're not doing that to you yet. There are a couple of hands. What were you thinking? Yes. All right, let's just break at the close and then see what RDI is. There's something else I probably want to do. Probably something I want to do to my payload, because if right now I'm sending a whole bunch of B's, what is that file descriptor going to be? It's going to be B, right? It's going to be whatever number that is. Does that tell me anything? No. What is a value I can place here that helps me reason about where it is in memory? I can put a cyclic value there. So let's do that. So now you see that we can use a cyclic value not just as the first thing that we're sending in a payload. This should be the second close. We print RDI. Boom. I have a cyclic value. We will cyclic find. I get 144. Okay. What do I want to put there? It's 144 B's, gets me to that file descriptor. What goes next?
File descriptor.
The file descriptor. Now, you can't know this for certain, but generally speaking, file descriptors are presented incrementally. And assuming we haven't opened anything else in the program, we know standard in is 0, standard out is 1, standard error is 2. So the next logical number would be 3. So how should I pack or structure this data? I just put 3. Do you want a P64 3?
I think there might be other values.
So how big is an int? Yes, an int, and this is something that somebody could get more technical on me and be like, technically it doesn't have to, and you're right. But generally speaking, on a 64-bit system, an int is going to be 32 bits or 4 bytes. We also can kind of recognize that because the value that we see here is 4 bytes. So what should I do? It's not P64, it's going to be P32. All right. Comparing that to our model of what's going on in memory, we're looking pretty good. But I don't know how 144 and hex 98 relate. How can I dynamically deal with this? I could subtract it in like hard code numbers, but that's guaranteed to be pain. How do I dynamically pad a string? We've done it already. L-just. So what I'm doing now is I'm going to say the contents plus equals, or I'm sorry, equals my exploit to contents L-just to hex 98, and I want to use, let's use the character C. Oops. All right, so this, what I'm doing here is I don't really have to care about this. I want to make sure when it's all done, it's that long, right? Whatever's left over, fill it up.
Yeah, you got it.
Does it need a comma?
Just separate the. And they also.
Thank you.
You're right.
And
Back
so
to
the-
two.
The first. and then-
See.
Yeah, first line and see.
Thank you. Normally I just run it, it explodes, and then we stare at it. You guys are good.
Now we're padding with zero, so it's C.
It's all a test. All right, making sure you're paying attention. All right, so we'll print. What is it? RDI. I get a 3. I lit Finny. So I'm coming back from the close. I'm now in the stack frame of write file, which is where I want to be. I don't want to be in the guts of the implementation stuff. How do I dump out 60 giant hex? Let's just do it at RSP. Okay. I don't know where the buffer started, but it's somewhere in the current stack frame. So if I start at RSP and dump out enough, I'll get to see it. I see my A's. I see my pointer. I see my B's. Where's my 3? There's my 3. It turns out there wasn't anything here for C. It perfectly lined up, right? Otherwise, we'd see 6, 3, 6, 3, 6, 3 somewhere down here.
I think it should
So should I put something right here? Or what happened?
Oh,
I thought we mapped it, so we were right next to the canary.
Well, yeah, I don't wanna.
we look like 7 bytes short right now.
Oh, you just want to add 4 more bytes? You want to add some D's? Type some D's on. What?
Yeah.
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 All right, like it's what would you do, right? Hopefully, we encounter the type of things you're going to do when you're on. You look at this, you're like, yeah, man, let's throw some D's.
We also forgot to overwrite the smallest value of the canary. So that's a null.
Okay.
So it's okay.
So I'm going to throw on not 4, we'll say 5 Ds, right?
Sure.
That should get me there. If we're thinking about things correctly, is this is our 3 or 4 bytes that represent the 3. You're saying I want to throw 4 Ds and I want to have a D right here.
Yeah.
Yeah. What happened?
Yeah.
It did it? Okay. What's going to happen when I continue execution from here?
It dies.
So I'm going to finish.
Yeah.
We have canary now.
Right? Like we got a canary, but we blew up. So is that canary any good to us or useful? Question. Yes.
You didn't get
Yeah, we didn't get the canary because there's
the pointer earlier has no bytes.
yeah.
Which is pretty much right there.
Yeah, somebody brought up a good point. When we look here, that first pointer has null bytes. What determines the end of the string? Null bytes. This is solvable.
This sucks.
This isn't the way to do it. How else can I get the canary?
You will just like instead of putting that address, we put the address where the canary would be, and like it should print out the canary. Like
Okay, so somebody, I think it was you pointed out that this value is alterable, right? So why not put the address of the canary there, right? Then instead of printing out my A's, the beginning of the puts is going to be the canary, and so I can just kind of skip over this, right? I'm abusing the functionality of the program to tell me its guts. I'm abusing those guts to reuse the functionality of the program to tell me more about it. And this is all just memory corruption. Just clever use of it. How do I figure out where the canary is relative to my leak? Oh, we've kind of already done that, haven't we? It was our leak plus hex 98, right? That gets me to the 8-byte chunk.
Plus 1 more.
Plus 1 more. So where does that go in my second payload? Or where do I put this value to make sense of it? Okay, so instead of P64 stat leak, which is where that pointer is, you want to place what? Stack leak plus hex 99. All right, let's go with it. All right, that's my first close. That's my second close. I'm going to slowly, let's disassemble write file because I want to find where is that puts call. I want to hang on to this just after puts now. So I'm going to break it write file plus 244. We'll continue. The reason I did that is I don't want it to explode in GDB, right? So puts has happened now. So I should see up above something. What did I see? That doesn't look like a canary, does it?
The
Yeah.
address that had look at it.
I'm pretty sure we may have messed up the math. Because we calculated 0x98 from after the address, but the stack leak that we have is from the beginning of the buffer.
Okay. So we can verify that, right? We could say boop, 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 boop. Examine 60 giant hex at RSP. This is the beginning of my buffer at AA0, right? And what I was calculating before, which was something that we talked about, right, was from here to the end. So that hex 98 wasn't the correct number. What I really need to find is the beginning of my, or the canary, which we see is right here. Boop. 8 minus.
Because the last one is done, so anyways it won't get.
Okay, we want to account for the null byte there. Do you like this?
No, it should be 6p39 because that's the address that we would have.
You want
The one at A8, 6b A8, the address. Below.
a up here, A8?
It's just right after the A's.
After the A's, we start, our payload starts at A's with AA0. You agree?
No,
Okay, then we're down here?
Yeah,
What am I looking
so
at?
we copy that value, the 7FFCDE196p39.
No, this is something we've already messed up. This has our addition in it,
Oh, right.
right? So if we start looking at things we've already got that are wrong, we're going to trip ourselves up. That's why I just was like, let's dump out the whole stack frame
Yeah.
and start from things that are known.
Yep, so that should be.
So if we go from, we want to get to the canary, which is going to be at C48 plus 1 for the null byte. And we are starting at AA0. So I believe this is the correct math. We're on the same page. All right. I got 1A9. I'm going to continue. I'm at the next close. We'll break at that same point I just did. Hopefully it's in here. It is not. We'll disassemble write file because I have horrible memory. Break at 244. Continue. Okay. Let's see, we're on the other side of puts. Did we get something? We got something different now. How do I verify that these bytes have something to do with the canary? They might not. I'm sorry? Right, but we skipped the null byte in our map, right? How can I use GDB to find out what the canary is? I could print out the stack, and somebody also said in the back, we could just say canary. So the canary is this value on this run. Does this number correspond with the nonsense that came out in any way, shape, or form?
Yes.
Okay, but the canary should be how many bytes?
We need to read them.
Okay, well, what are the other bytes?
RPP.
Yes, the saved RBP. Generally speaking, when you leak out a canary, you're going to also get the bytes of the saved RBP. May or may not be useful, happens to be a stack leak. Fun fact. Okay, so in my code, do I just read, how do I get this? P receive until, we can look at what the program output here, right? We have this nice guide. What do I want to receive until before I get the bytes? Offset, colon, space. Then I'm going to P receive 7. This should be my canary. Where I need to do what to it? Okay, I am going to R just to 8. with null bytes. And then we will U64 it. And then as a sanity check, we'll print out the hex of our canary. Yes? All right. So you see how this is an iterative process, right? I'm trying something, I have GDB attached to it, I'm reasoning about what's happening, I'm finding the next memory corruption or what is the thing that's exploding. One of these days, my brain will work. 244. Okay. Am I at the wrong spot?
Yes.
Okay. Okay, so I didn't make it pretty, but does this match this? This is the leftover saved RVP of just the program outputting. My code is printing out this value right here as the canary, which should match with what GDB is telling me is the canary. So I have now confirmed that I found the same value. Yeah? All right. How do I use these? What do I have to do to my exploit code now?
Just craft the payload with the canary and override the return address.
Okay. So can I do it in exploit 2? In that file? Right, I need a third file, right? We have to do complex interaction between passing, communicating with this program over standard in, we're dynamically creating these files and making it all work. Now, FizzBuzz doesn't have this problem, but other challenges will, so I figured we might as well get started on it now.
You name it something fun.
What's something fun?
Cool file.
Cool file. All right. We can name things whatever you want as long as you remember them, because I won't. Cool file contents. We're going to open the cool file. All right. And what is going to be in cool file contents? I'm going to yoink what we had over here to start. Okay. The L just wasn't doing anything. So what do I want to change? What do I need to do?
For these, then the canary.
All right.
Something for RV2.
Let's just keep everything the same. We'll have this useless L just. All right, let's get superstition about it. Cool file. All right. You want to add 4Ds? And what do I do with the canary?
P64.
Right, it's an 8-byte value. We're going to P64 the canary.
Make sure you change the split two contents.
And yes, good. This is the kind of thing that will eat hours. Something tells me you're familiar with that. All right, that gets me the canary. What else do I need to do? How do I get to the saved grip? I'm very close. What is immediately after?
I 8 bytes for RV2.
8 bytes for the saved RVP. All right, my suggestion, much like how we are incrementing A, B, C, D, there we go. Cool contents plus equals E times 8. Because then if we see the value, we know immediately in our code where it's coming from, which section. All right, what do I want to overwrite saved RIP to be? Okay, the start of the buffer. Do I have the start of the buffer? Okay, where is it in my code? Stackly. All right, so we will say plus P64 of stackly. You want to just run this and see if we get there? Or
we can add the shell code.
okay. Yeah, well, let's just make sure we're getting there, right? Incremental steps. You write too much code, and then when something goes wrong, you're just like, I don't know where it is. All right, get to the second close. I should be able to go. Oh, did somebody point out what I was doing wrong? I think I just remembered it in real time. I did the same thing on the second payload. What did I do here? Did I send my cool file? Where's my cool file? I have my cool file contents. I didn't write a file. Okay, I am writing a file. I'm not passing it correctly to the program. All right. I caught myself on this one. Cool file. All right, there's my first close. There's my second close. There's my third close. We notice that our backtrace is now looking kind of funky, right? That's because the way that GDB figures out where these calls go is with saved RBP, which we have now made a whole bunch of Ds. And so it's like it's going to have a bad time figuring out what's going on. All right, we'll get out of close. Let's examine 60 giant hex at RSP as we have been. Let's info frame. Saved RIP is this here, 430. 430, that is the beginning of my buffer. We did do math correctly. All right, we are like 99% of the way there. And this is where, okay, I've successfully made it there. How do I put the shellcode in at the beginning? Cool file contents right here at the beginning. I have BA times 64. Does anyone know a magic way to generate super helpful shellcode? Okay. Shellcraft? You like Chmod? No, I'm a fan of Cat too.
Yeah.
Personally.
Sometimes my buffer doesn't have enough space for cat.
Okay, I'm just going to comment this right now because we need to keep this around for context. Is this what I want to do? There's actually a bit more. Yes. Aren't I, right now I'm altering cool file contents. Yeah. That means that it's going to mess up all of the math that we've done.
Well, it's shellcode doesn't overwrite it.
Don't I overwrite the shellcode? Cool file contents is the last file that I'm putting. This overwrite is an LJust, which means it's going to retain the contents and then pad it. Right? So I'm not overwriting it here. I'm redefining it as what it was with a guarantee of at least a length of hex 98, and any extra bytes that it needs will be the letter C. That is what is happening.
Wait, how are we sure the shell craft will be, is it because of the flash notes?
So the question where this isn't correct, that I want to finish this. I'm going to run late if you guys will hang out. You're free to leave because I understand your time is valuable. But I want to get the flag here. The question was, how do I know that the stack is executable? All right, how do I know this is something that will be executed? We can run checksec. We see that the stack is executable. The other thing that we could do in GDB is we could run a command and look at the pages of memory. What command do I do to use that? VMMap. And that would show us as well. I'm happy to do it in a second, but first we got to fix this code. So what is the output of shellcraft.cat2? Are these bytes? No. It turns out these are the assembly instructions.
ASM.
Right? We need to wrap it in ASM. Okay? How do I make sure that once I start my payload with these bytes, I maintain my length here of 264? We could do some crazy math. Or we could let the computer do the math and use LJust. I want to LJust this to be at least 264 lengths, and let's use Z. Right? Just as long as it's something different. This will work as long as the assembly bytes are less than 264 bytes. Was that a hand?
Yeah.
Yes.
Yes. What's the difference between shellcraft.cat2 and shellcraft.cat2?
Honestly, I don't know. We can find out as soon as I end the stream.
Okay.
I just want to see if I can get this to fire, because then I'm going to feel really good about this demo. All right. So let's fire our payload one more time. All right. We're going to continue through the first close. We're going to continue through the second close. I want to see it. So I'm going to fini. I want to disassemble a write file. I'm going to break at this ret. So I want to break at write file plus 266. That looks like shellcraft shellcode. If you've ever seen it. It has a very recognizable pattern. And as we step through this, it's making everything to open, read, and write. Unfortunately, we sig ill. Did we get the flag? No. You know why? Because this is a demo challenge, and it is, since I just built it, right? And we look at a.out. It is not set UID, right? It's meant to make it easier for you guys to play around with this as a demo. But we can chmod or sudo chown a.out, make it owned by root, and then we can sudo chmod u+s to make it set UID. All right, I saw in GDB this should work. Let's get rid of the GDB. Okay. All right, 4 or 5 minutes late, but we did it. Hopefully this was useful. This is the type of logic you're going to need to solve FizzBuzz.
All right.
All right. It is intended to be difficult. So if you don't solve it, that's okay. Not the end of the world. I'm going to try and put hard challenges like this at the end of modules where it makes sense.
Yeah.
Like,
I you make that part of the party, like what?
That's not really. I mean, it's
Yeah.
So it's tricky, but yeah.
Okay. So the question was, I'm still streaming, just so you know. Don't like give away your password. If I throw GDB back on this, I will get this is fine. When I type VMMap, we see the stack here is executable. So anywhere in this range is a valid place for us to place it. All right, but we have to be able to write there, right? And so for this example,
like if
yes, anywhere in this region of memory. And since which is the stack, and this challenge happens to be storing our buffer on the stack. So that so the RDP and RDP decide where the stack range is. That's for the current function, right? That's going to be actually a pretty small region of memory. These addresses are really far apart, so we have lots of space, right? Because we don't care if it's blow up, right? We just care if we got executions or shell code. Once it outputs the flag, if it blows up, we don't care, right? We got what we want. All right. With that, I'm going to end the stream. Twitch. Hopefully this was a good time. Goodbye, good luck. I do have office hours. What's today? Thursday? On Saturday at whatever time I said on Tuesday. All right, Michael has office hours tomorrow. Ask him questions. I'm
Discord 10 a.m.
Who's awake at 10 a.m.?
That's Michael, not me. All right, that's why this class is at 4:30.
Yeah.
So Saturday at 2 p.m. on the Discord. I'll be hanging out and talking or crying. You can play Stump Robert. It'll be fun. All right, good luck, everybody.